Hi guys, so today we're going to be discussing Leetcode question 448. Find all numbers disappeared in an array. So the question is, given an array nums of n integers where nums I is in the range 1 to n, return an array of all the integers in the range 1 to n that do not appear in the nums. So for example, we have this array nums 4 3 2 7 8 2 3 1, a nums array in the range of 1 to 8. So the missing numbers are obviously, as you can see, 5 and 6. So how can we go about this? So the first approach is using a count sort approach. So what is the maximum element in the array, which is 8? So we create a separate array as we do in count sort of length 8 plus 1. So basically the maximum index should be 8, 5, 6, 7 and 8. And initially all the values would be 0. So what is the count sort approach? Basically, whatever element that you get in the original array, go to that index in the count sort array and increment the value there by 1. So when I is equals to 0, basically we're working with this nums 0, the element there is 4, so we go to index 4 and increment the value there by 1. Similarly, when I is equals to 1, nums I, that is nums 1, becomes 3. We go to a new index 3 in the count sort array and increment whatever the value there is by 1. We keep on working with this. So when I is equals to 2, nums I becomes 2. We go to index 2 and increment the value there by 1. When I is equals to 3, nums I is 7. We go to index 7 in the new count sort array and increment the value there by 1. Similarly, we keep making such changes. For I is equals to 8, new index would be 8. The value there will be 1. So this is done. 5 and 6 are already encountered, so we can just increment these values by 1, whatever the value there is, and at index 7 for the last value we have 1, so we go to index 1 and increment the value there by 1. So except for I is equals to 0, from 1 to n being 8 in this case, what are the missing numbers here? Everything has been encountered since their value is greater than 0. But there are two integers whose value is not greater than 0. Those are equal to 0. That means they've never been encountered. So these are our missing numbers, which is 5 to 6. This uses an additional memory of O of n. So there's a space complexity of O of n, the additional memory as well. So how can we solve this question without using additional memory? So the idea is to use a modified count sort approach, which basically does the count sort approach only, but it is an in-place count sort approach. So what is the algorithm? So the algorithm is use count sort. How? Go to the new index as usually we calculated nums I, but this time minus 1, because indexing starts from 0, right? So what does this value say? We've encountered this element at index equals to element minus 1. So that is what this signifies. And at the new index, as you can see, multiply whatever the absolute value of that value is there by minus 1, suggesting that we've encountered this element and we multiplied by minus 1 to preserve the actual values in the original array. So next time whenever we're going over that index, we just need to get the absolute value of it. Again, before we move forward, one correction: this part needs to be absolute value of nums I. Alright, so let's understand this example via an example below. So let's say this is the example that we have. So I is equals to 1, right? So I is equals to 0 initially, right? What is the element there? Absolute value of nums I, that is 4 right now. So the new index would be 4 minus 1, that is 3. Nums or in nums 3, so basically at this index, whatever the value there is already 7, multiply that by minus 1, so this becomes minus 7. Alright, so now we're working with I is equals to 1. So now we work with I is equals to 1. So at I is equals to 1, what is nums I? Absolute value of nums I, not nums I. Absolute value of nums I, that is 3, right? Absolute value of nums 1, 3. So what would be the new index? 3 minus 1, that is 2. And what would be the new updated value? Nums new index, whatever the absolute value is there at this new index, so that is here, right? Whatever the value there is, multiply that by minus 1 and put it there. So this becomes minus 2. So now we're working with I is equals to 2. At I is equals to 2, what is the value? What is the absolute value? Nums I is minus 2, but what is the absolute value of nums I? That is 2. So this becomes 2. What is the new index then? 2 minus 1 is 1. So 1. So we go to index 1, that is this in this case, and whatever the value there is, we get that value, absolute value of that, and multiply it by minus 1, minus 3. Notice the minus signifies that we've encountered this element, the element at this index, and minus also preserves the original values of the array, so we do not miss any information. So next we move on to when I is equals to 3. When I is equals to 3, the element value becomes minus 7. However, we're talking about the absolute value of element. So absolute value of nums I becomes absolute value of minus 7, which is 7. So the new index is 7 minus 1, which is 6. So we go to index 6, that is here in this case, and whatever the absolute value there is, that is 3 in this case, we multiply it by minus 1. So minus 3. I'll just clean this up a bit. So now we're working with I is equals to 4. So when I is equals to 4, the absolute value there at index 4 in nums array is 8, right? So the new index would be 8 minus 1, that is 7. So what do we do in the next step? We go to this index I is equals to 7, and whatever the value there is, we multiply, get the absolute value of that, and then multiply it by minus 1. So absolute value of 1 is 1, and multiplying it by minus 1 gives us minus 1. So next I is equals to 5. That gives us absolute value at index 5, that is 2. So what would be the new index? 1. So whatever the value there is, get the absolute value of that at new index. In new index is 1. So here basically I'll just write this in green. This has already been encountered, so we're just encountering it again, so we do not really need to make any change. So the absolute value of whatever there is, so absolute value of minus 3, that is 3 into minus 1, that gives us again minus 3. So this becomes minus 3. Okay, so now I is equals to 6. When I is equals to 6, what is the new element? Absolute value of the element at index 6, that is absolute value of minus 3, 3. What is the new index then? Element minus 1, 3 minus 1, that is 2. What the new updated value at new index 2 would be whatever the value there is, get the absolute value of that and multiply it by minus 1. So this would give us again minus 2. No change made it. Basically because we have already encountered this, so we do not need to make any change. Then we move on to I is equals to 7, the last element. So what would be the element value in this case? Absolute value of whatever there is. So absolute value of minus 1 gives us 1. So the new index would be 0. So what do we do next? We update the value at new index equal to 0. Whatever there is, get the absolute value of that. So absolute value of 4, and so absolute value of 4 would be 4, multiply it by minus 1. So this would become minus 4. Notice again I'm reiterating, the minus only signifies two things. That index value, the element that is supposed to be at that index is already encountered, and by minus we're also preserving the original values of the array, so we do not miss any information. So now the array finally becomes something like this. Nums is equals to minus 4, minus 3, minus 2, minus 7, 8, 2, 3, sorry, minus 3 and minus 1. Now that this has been done, this is the index 0, 1, 2, 3, 4, 5, 6, 7. Once this approach has been completed, once this loop has been completed, all we need to do is run an O of n loop again to iterate over the array and see where the index value, the element values are positive. So in this case, I is equals to 0, the index value is negative, so that means we have encountered this element, so we do not need to, this is not missing. I is equals to 1, element value is negative, not missing. This is also negative, not missing, negative, not missing. but these two, I is equals to 4 and 5, I is equals to 4 and 5, their values are still positive. So that means we never made any changes to the values at these places. That means we never encountered them in our array. Not the values 8 and 2, but the values at these indexes. So what would have been the element to get these indexes? Remember that we were always doing the new index equals to the whatever the element value is minus 1. So the actual element would be new index plus 1. So since index is 4 and 5 plus 1, so the actual elements would be 5 and 6. So this is our answer for now. For further elements, when I is equals to 6, I is equals to 6, it's negative, so this has been encountered. I is equals to 7, value is minus 1, so this has also been encountered. So this element 5 and 6 is our answer. So I hope you guys understood this video. I hope this video helped you understand the algorithm behind it and why we're doing it, how to solve this question. I'll attach the link to the GitHub code in the video below, and also to link to my social profiles for you guys to check it out. Please feel free to provide any feedback or any other questions that you want me to help you with. I'll be more than happy to assist you with those questions. Thank you for your time, guys. Have a great day. Keep coding.